Record on this computer. There we go. All right. Yeah. Sorry if I didn't answer any emails. I got my booster on Friday evening, and then was okay for half of Saturday, and then I just really wanted to do nothing but rest. So, and then Sunday I was just busy with family stuff. So, if I didn't get to you, apologies. If it was super urgent, I think I got all those super urgent emails, but if I didn't, I'm sorry. But in general, Tuesday, Thursday, Wednesdays, Tuesday, Thursday evenings and Wednesdays, pretty much all day. If you need to schedule an ad hoc meeting with me, I'm available. I've been trying to make myself really available during those days. All right, so let's go ahead and talk about the next upcoming assignment, because it's got this very interesting quirk. And yes, I see that you can't see that. So, okay, again, multi-factor authentication. No, okay. Another thing I would note is that I would expect, another surge of COVID and influenza, coming. So, consider wearing a mask. Definitely get vaccinated for both with both the bivalent boost vaccine and the influenza vaccine, because influenza is no joke. It really isn't. So let's go ahead and see like I was mentioning, in the assignments, we go to our assignments, I should have broadcast that due dates for all of them. So password cracking, graph setup. Password cracking and graph setup are due after the break, the Thanksgiving break. Password cracking is due December 5th, which is the exact last possible day I can make things due. You're welcome. It's not really too bad. Notice that the graph setup is 50 points. That's because it's a rather small assignment. I wouldn't even normally include it, except because you're going to be using an external library for doing password cracking. And this might be your first time using jar files, or some other kind of external library that's not built into your programming language of choice. Then that is why I have this. Basically, a lot of this one this one's just as much about using an external library as it is about using graphs. And then password cracking is a problem for Project Euler. I really like. It's a it's a graphing problem, specifically a directed acyclic graph problem dressed up as a security problem. Sorting algorithms. I cut that last semester, but I don't think I'll need to cut this semester. That one is less of a programming assignment and more of a data presentation assignment and simulation assignment. So in other words, you're going to spend a decent amount of time in Excel in that one, just simply creating graphs for your data. For that one, for these last three assignments, by the way, you get to use any programming language you choose. I highly recommend using Python or Java because they have the useful libraries. Python especially has nice graphing libraries. And for sorting algorithms, I am going to explicitly say right now, you want to go out on the internet and copy these, the sorting algorithm that somebody else wrote and included in your code rather than writing the sorting algorithm yourself. Because what the objective of that one to do is that you're going to be modifying the sorting algorithm so that you can keep track of the number of comparisons and the number of swaps. In other words, checking to see if two items are out of order and need to be changed, and checking the actual number of changes you do, which is, depending on the sorting algorithm, very expensive, depending on the context, can be very expensive. So the Cheater's Hangman is our last big assignment. It's due November 7th currently. It's our last big assignment. It covers sets, maps, and hash tables. It's the assignment after the index tree assignment, which is the one I'll be talking about today. Notice that is worth 200 points, just like the other big assignment. That one you can do Hangman, or if you so choose, because you enjoy Wordle, you can do the same thing, but do Wordle instead. Because the entire logic behind Cheaters, between the cheating of Cheaters Hangman applies to Wordle. Essentially, you are making a game that the user has as low of a chance of winning as possible. And that what the computer is doing is that it's breaking the rules. It does not choose a word. It does not commit to a word. It just pretends to. And then when the player loses, it tells it a word that would that fits the guesses that they've made. But you can't just simply say no to everything, because then you can get your program cornered. The other ones we want are, so index tree, I really enjoy this one. Because it tells this one is file reading. I've given you an index node and an index tree. The index node, this was before I started putting things inside my nodes inside my objects as private classes, so that's why they're separate. And also the reason I like this is because you'll be reading a specific file. Specifically, you're going to be reading the complete works of Shakespeare downloaded from Project Gutenberg. This file, I'll download it right now, is fairly large. Let's see how large it is. 5.3 megabytes. That's actually, and that is actually kind of relevant here. So project, and I'll show you why rather than having you hit into it yourself, but you'll probably hit into it anyway. File reading. This window. Okay. And now I will just simply grab this and dump it here. And yes, I still have to fix exams. I am so sorry. So notice that I've dragged this file into here. The file size, 5.56, exceeds the configured limit, 2.56 megabytes. Code Insight features may not be available. This should be a warning of some kind that working with large files actually has consequences, in the sense that basically that, it reads and scrolls through it just fine. But what's going to happen is that when you go through and you work on your index, which it requires you to print out your index, essentially saying this word occurs on these lines, that's the objective of this, you're going to be like, half the output's missing, in the terminal. Half of my output, I can't read half my output, and my output starts in the M's for some reason, or I'm missing all the up. And the reason is that your console down here has that this says is also dealing with this. The configured file size exceeds the configured limit, 2.56. In other words, this just because big files are hard to work with, especially if you're like trying to do code insights, there's basically is a limit to how big they'll let the file be and do that. Similarly, your console, because of old rules, has a buffer. Which is generally 1 megabyte. 1024 kilobytes. Okay. So that means that, and remember, our file is bigger than that. So that means if we print out more data than can be contained in a megabyte, it's got to do something with that. And specifically what's going to do is that it will just simply start throwing away the oldest lines so it can make room for the newest lines. And so that's not an issue with your output at all. That's just simply your console. And that's not an issue with when you're trying to demo it. It's just something to be aware of, that if you try to print out all the stuff and it looks like some of your stuff is missing, it's probably because you've hit the console limit, because you have a large file. Yes. I could just simply output it to a new text file. That is one of the two ways to get around it. When you have large output, one way to get around it is to write a file. This other way to get around it is just, hit this button and increase the buffer. Or some other, I'm not sure if that's the right button, but the point being is that your output has a buffer size. Similarly over here for your terminal, which is, the actual built-in terminal that you can interact with your computer with, has a scroll back buffer size of so many lines instead, 5,000 lines. So if you print out more than 5,000 lines, you'll get the same issue. Again, this is not an error with your code. It's not going to prevent you from demoing it, but it will, if you didn't know about it, it will basically be something that eats at you because you don't know what's going on and you think you've messed up. Okay. And that's part of the reason I like working with this. Turns out 5 megabytes is a lot of data, even though it doesn't seem like it. Similarly, depending on how you implement this, this can take like forever this program can take like minutes to run if you don't implement it like correctly. Oh, I exaggerate, like a minute to run. An annoying amount of time, especially if you print out everything, then it will definitely take minutes to run. All right, so keep that in mind. But overall, this assignment isn't actually that hard because what you're going to be doing is just simply modifying you're going to be basically implementing the add and remove methods for a binary search tree, just in the context of this. And the add and remove methods are basically can be pulled from my code that I do in my lecture videos and then modified for this one. The biggest kind of brain bendy thing is that this is a data structure, a tree, where the nodes in the data structure hold other data structures, lists. So that is kind of the thing to wrap your head around. Sometimes the best way to arrange things is to have data structures hold other data structures. And when you kind of do it, it makes sense. Now, ideally also there's another way to do this, which is to use a tree map, which is built into Java, but I want you to do it this way. And we certainly don't want to use a hash map here for those of you who know, because hash maps don't care about order, and we want things in alphabetical order. All right, so next exam. First off, I always give at least a week's lead before this, and this is not going to be next week, because I want to give the exam probably, let's see, I have that due November 7th. When is that? So possibly November 3rd would be that, or November 8th, depending. Will probably be the exam. More details to come, but that basically I want you to have the ability. Basically, it's going to be primarily over trees, so plenty of time to master trees with like a question or two about mostly over trees, question about Huffman encoding, a question about heaps, which are basically tied together and kind of bundled with trees, and then maybe one question about maps and how to do that. The most typical, I'm gonna ask you a boring question for maps, like given a text, given a big string, tell me how often each word appears, which is easy to do once you understand how to do maps. Yes.
So it's not next week?
No, not next week.
Okay.
Yeah, it's going to be like the 3rd or the 8th, and you'll get a practice exam a week beforehand. Okay. The way we do that, and the way that I'll do this for the upcoming exam, based off the feedback that I got from you, for this kind of group exam thing, is that the solo portion will be on paper, and I will ask similar but different questions on a paper exam. Okay, so that way that it is not just a matter of just simply copy pasting the best answers in, and you don't necessarily pile around a computer. Again, with paper, and because you don't know how I grade paper, like you forget a semicolon or a curly brace somewhere and your code doesn't compile. I don't care. The most I'll knock off for like a grammatical error like that is like a point, if it's like super egregious, which is normally not. I mean, because that's just simple, oh, the compiler would have caught that kind of stuff. and you're working fast and you're human, you're gonna make a mistake like that. Taking, taking points off for that would be kind of just mean and silly. But the main thing I care about is, are you basically checking the boxes on my rubrics? Making sure, okay, like this one, for example, if it was a file reading question, and basically so for example, like for 1051, I have a question about like reading a file and adding up all the even numbers in it. And it's like, so I've got a tick box. Did you open the file? Did you have code? That's some points. Did you print out an answer? That's some points. Did you actually add numbers together at some point? Were you able to distinguish whether or not numbers were even or odd, correctly? That's another set of points. So, checking the tick boxes the minute of the small tasks in there. There will be more details as we get there, but I'm just trying to say that basically it will be on the third or the, oh, sorry, wait, we do our exams on there. Sorry, hold on. We do our exams in lab. So it would be 4th or 11th, most likely the 4th. There we go, 4th or 11th, because that would give us the most time to do in lab. Most likely the 4th. So that way, if you need to, if you need to make some kind of side arrangement with me, like because your sister has a wedding the next day, or something like that, you can know in plenty of time. Okay. All right, with that, here's what I'm gonna do. So first off, again, there's corrections to be done for the exam, and I'll go into, so correcting, I think it's question 6. If you show me your correction, I'll go ahead and like enter in the corrected, the corrected number of points for your exam, right? This is available for even people who didn't miss the question, because that's the only fair way to do that. If you don't give me a correct answer, I'll just simply tell you to go away until you do. Okay, so and I'm not, and I don't really have a hard time limit on that. I just would, prefer sooner rather than later. Okay. I don't want like a pile of 10 people coming in at the end of the semester to deal with that. All right, so that's what I got for today. Otherwise, I'll be happy to take demos, answer questions, et cetera, et cetera.